Good day. Today we will be doing June 2022, paper 2, question 4. Okay, let's take a look at the question. So it says here, in the diagram centered at M, AB is drawn. T and R, so here's T and R, 6 to 0, are the x-intercepts. We've got a tangent drawn to the circle at K, 5 to 7. Okay, so what I'm going to do is I'm going to draw this out in my paper, so we can refer to it and draw on it if needed. So here's my T. Here's R, which is 6 to 0, 0. Here we've got our center, M, A, B, and we've got a tangent, which is K, 5 to 7. Okay, so the first question says M is a point on the line y is equal to x plus 1. Okay, write B in terms of A. So my coordinates are A and B. So if it's y is equal to x plus 1, we're going to substitute. My y is B and my x is A plus 1. Next is calculate the coordinates of M. Okay, so what we can notice here is we can notice that MR, okay, this is a key point, MR and MK are both the radius of a circle. And if we go and take a look at our formula sheet, if we look at our formula sheet, a distance formula, here's the distance formula, x minus a plus y minus b is equal to r squared, which means that my radius squared, because we want to calculate the distance, times radius squared will be equal. Let's go back up. So let me just revise what I just said. I said that MR is equal to the radius and also MK, but we want to use distance formula. And so to use distance formula, we need to square them because we want to calculate the radius squared. That is how we calculate the distance. So that is what we need to calculate now. And we know that the formula is x minus a squared plus y minus b squared is equal to r squared. So let's do that. Mr squared is equal to mk squared. X minus a squared plus y minus b squared is equal to x minus a squared plus y minus b squared. This is going to be a long sum because it is 5 marks. Okay, so let's start with MR. So with M, we don't know what it is, so it's a minus 6 squared plus b, my m is y is b, minus 0 squared. With mk, it's a minus 5 squared plus y is b minus 7 squared. Now, because we want to calculate the coordinates, we need to substitute in here. So we're going to use this to substitute into my equations that we have the same variables. So here I'm going to have a minus 6 squared plus a plus 1 minus 0 squared is equal to a minus 5 squared plus a plus 1 minus 5 squared. So now we can simplify. So on this side, I'm going to simplify, and on this side, I'm going to simplify. Here I made an error. It's actually 7. So sorry about that. The y value here was 7. Okay, now we have all the same variables, so we can simplify. Let's simplify a minus 6 squared. So I'm going to do that on a separate page because I don't want you to get confused. So a minus 6 squared is a minus 6, a minus 6. This should be very simple to do in grade 12, but I'll just revise it quickly. So it's going to be a squared minus 6a minus 6a plus 36, because a minus and a minus gives me a positive. So a squared minus 12a plus 36. The other one that we have is a plus 1 squared. So a plus 1, now it should be faster for you. A squared, 1a plus 1a is 2a plus 1. Now we're going to simplify that. So let's write it all out. A squared minus 12a plus 36 plus a squared plus 2a plus 1. On the other side, we're going to simplify. A minus 5 squared. So a minus 5, we get a squared minus 5a is minus 10a plus 25. So a squared minus 10a plus 25. And here we're going to have a minus 6. Same thing. Okay, so now we're noticing here that we have also positive a minus 6 squared. And what does that mean to us? That means that we have the same on both sides. So we can cross it out, because we cross out what's the same on both sides. A minus 6, a minus 6. I'll repeat what I just said. A plus 1 minus 7 gives me a minus 6 squared. And we also have the a minus 6 squared on this side, so we can cross it out because we have an equal side in the middle. And it basically cancels each other out, because if I were to simplify this, I'd get the same thing, a squared minus 12a plus 36, and I'd take it to the other side and it would all give me 0. So now what I have left is a squared plus 2a plus 1 is equal to a squared minus 10a plus 25. We can simplify. So a squared minus that cancels out. 2a, take the 10a to the other side, plus 10a is equal to 25 minus 1. 12a is equal to 24. Divide by 12 on both sides. A is equal to 2. Okay, we have my a value of m, finally. It's a long process, and we can use this and substitute back to calculate the b value. So b is equal to 2 plus 1, b is equal to 3. So my m is going to be 2 is to 3. Okay, so now that we have calculated the coordinates of m, we can move on to the next question. The next question says, if you can see properly, it says if the coordinates of m are 2 and 3, so we know we have calculated the correct value. Calculate the length of the radius of the circle. So they want the length of the radius of the circle. So this, how many marks is this question? This is 2 marks, fairly easy, because what were we saying earlier? We were saying that MR is the radius, MK is the radius. So we just have to substitute either part in to find the radius, because we know our radius formula. So 4.2.1, we're going to have x minus a, always write your formula out because you know what you're doing then. Y minus b squared is equal to r squared. Okay, so let's say we're working with MR. Okay, the reason they give you the coordinates is to avoid errors. So in case you got the coordinates wrong, you weren't able to calculate, you now know what the coordinates are, so you don't get the remainder marks wrong. Okay, so we know that x of m is 2. And here it's minus 6 squared plus y of m is 3 minus 0 squared, and that is going to be equal to my r squared. So here it's going to be negative 4 squared plus 3 squared is equal to r squared, and we're going to have 16 plus 9 is equal to r squared. 25 is equal to r squared. So r is the root of 25. R is 5. And that is my radius. Okay, 4.2.2 says determine TR. Also for 2 marks, also checking your ability to understand distance formula. So if we were to find T, we can find T now from the distance. So we now know that r squared is 5. 4.2.2. We know our distance formula, r squared is equal to x minus a squared plus y minus b squared. And we know that t has the coordinates of an x value of 0. We just don't know its, an xy value of 0. We don't know my x value. Okay, we know what m is. M is 2, 2, 3. And we know that r squared is 25, so we can substitute to find that value of x. So let's say this is my tx value minus my m, which is 2 squared, plus my y value of t is 0 minus 3. 25 is equal to x minus 2 squared plus minus 3 squared is 9. 25 minus 9 is 16. Here we're going to have x squared minus 4x plus 4. Let's make the 0. We can take the 16 to the other side. Minus 4x plus 4 minus 16. 0 is equal to x squared minus 4x. 4 minus 16 is going to be negative 12. We're going to find factors. X. Factors of 12 is going to be 4 and 3. But that's not going to give me 4. So what else can I do? I can do 6 and 2. My 6 is going to be negative because we want a negative value in the middle, and my 2 is going to be positive. Therefore, x minus 6 is equal to 0. X plus 2 is equal to 0. X would be equal to 6. X would be equal to negative 2. So I did this in a very long method just so we can determine where we get our values from. But therefore, t x value has to be negative 2 because it's sitting on the negative part of the axis. Okay, so tr is actually what we need. And t we now know is negative 2, 0. And r is 6, 0. So we just have to add my units. So 2 plus 6 is going to be equal to 8 units. TR is 8 units. Okay. Let's now take a look at 4.3. 4.3 says determine the equation of the tangent to the circle at K. Write your answer in the form as y is equal to mx plus c. So they're wanting you to determine basically the formula for the tangent at K, which is what we have here. So firstly, for this question 4.3, y is equal to mx plus c, two things that we need: gradient and c-intercept. So we can find gradient using the values of m and k. Okay, so we're going to find gradient of m from the radius or from the using the values of m and k. So m is what we calculated to be 2, 3. And k is 5, 7. You should know radius formula, and you should know gradient formula, and you shouldn't need to refer back. But if you do, it's y2 minus y1 over x2 minus x1. It saves you a lot of time knowing your formula, so you don't have to go back and forth to the formula page. 7 minus 3, my y values. 5 minus 2, my x values. 7 minus 3, 4. 5 minus 2, 3. That's 4 over 3. Now this is the gradient. Let's draw the circle again. Here's T. Here's R. Here's M. And here's K. We're working with K now. We want this K. But what we actually calculated now is the gradient of MK. How are we going to calculate the gradient of this line K? What do we know about gradient? We know that the gradient of MK times the gradient of K, what is happening here? It's perpendicular. So it's equal to -1. So we know that this is now 4 over 3. We want this gradient. This is -1. What is this going to be? It's going to be -3 over 4. Now that we have the gradient, -3 over 4, we want C. We can substitute our K values to find that value. Okay, so let's substitute. My Y is 7 is equal to M, -3 over 4. X is 5 plus C. So 7 is equal to 5 times -3 is 15 over 4 plus C. I'm going to take it to the other side. 7 plus 15 over 4 is equal to C. C is therefore equal to 43 over 4. How do we do that? We say 7 times 4, so the 7 is also 28 over 4. So 43 over 4. So therefore, my equation is y is equal to gradient -3 over 4x plus 43 over 4. Okay, we are nearly done. We're on our last question. The last question says, a horizontal line. Let's draw my circle once again, just so that it makes it easier for us to visualize. A horizontal line is drawn as a tangent to the circle M at a point in CD, which we don't know the coordinates of, where D is less than 0. So we've got a new tangent, but it's N with the coordinates C and D. But this y value of D is less than 0, which means it's sitting down here. So I'm going to have to draw it somewhat like this. Okay. Firstly, it says write down the coordinates of N. And I think it's important for us now to actually draw it on the original, because we're not going to get the coordinates if we don't specifically look here. If I draw it right here, okay, it's a tangent and it's going directly down, you would see that it corresponds to the M value, which is 2. And if it's corresponding to 2, then we know that it has an X value of 2. And if it has an X value of 2 and we calculate across here, it becomes -2. So this is a question where you actually have to draw it on your paper, and you would therefore see exactly where it is situated. The last question says, determine the equation of the circle centered at N and passing through T. So now we know our N coordinates. We know T as well, which we calculated to be -2 and 0, we can just substitute into this formula. So x minus a, the formula that is given in the question, plus y minus b squared is equal to r squared. So let's use -2 from my t, and that will correspond to y minus 2 plus 2. And they want the answer in the form of this, so we're calculating the value of r. So -4 squared plus 2 squared, 16 plus 4 is equal to 20. So r squared is equal to 20. So my formula is going to be x minus 2 squared plus y plus 2 squared is equal to 20 for the circle at n. Okay, now that we have completed all our questions, let's go through it all. We've done a lot in this paper. So very important was this question of calculating the coordinates of m. It was a 5-mark question. Required you to use question 1, which was 1 mark, to realize how to calculate question 5. The 5-mark question of calculating the coordinates of m had a lot of marks that you had to do. So firstly, you got the first mark for equating radii. The second mark was for solving simultaneously, and substituting that a plus 1 was the third mark. And you got a mark for here and your answer, and here you didn't get a mark there. So it was 5 marks in total. Okay, the next question was a 2-mark question calculating the radius of the circle, which was fairly easy. It was making use of the distance formula. TR, we went about it in a long way just to show how we got those values, but technically you just needed to know that, and then you had your answer, 2 marks. 4.3, we were calculating the formula. Here you got marks for substituting to find the gradient, this gradient, this gradient. Oh, this was a 5-mark question to find this formula, and it was fairly easy. And then substituting to find c, and then your answer, 5 marks. And then the last part was n, where you actually had to draw. It's a 2-mark question, and the last one was 3 marks for substituting my r value and the answer. And in total, it was a question worth 20 marks. Thank you so much. We will continue looking at paper 2 questions.